Unit 9, Lesson 5, we're going to revisit the concept of average rate of change. Let's start with a warm-up. We're given two functions. H of x is equal to 2 raised to the x, and j of x is equal to 1/2 raised to the x. For what value or values of x are the two functions equal? Put the video on hold and try it. The easiest way to find the answer is to enter both functions into your graphing calculator and look at the point of intersection. And we can see that the point of intersection is 0, 1. So we express our answer as a point, make sure to have parentheses surrounding it, and box in the answer. The average rate of change formula is actually the change in our y values over the change in their x values. Let's go through an example. August 16th, Regents question number 31. The distance needed to stop a car after applying the brakes varies directly with the inverse of the square of the car's speed. The table below shows the stopping distances for various speed levels. So we're given a table of values where our x variable or our independent variable is speed and our output is braking distance. So for part A, they want you to find the average rate of change in the braking distance in feet per miles per hour between one car traveling at 50 miles per hour and a second one traveling at 70 miles per hour. So the average rate of change is equal to the change in our y values over the change of our x values. So we're looking at the difference of when we're at 70 miles per hour versus 50 miles per hour. The stopping distance for 70 miles per hour is 306.25, and for 50 miles per hour, it's 156.25. Let's enter this in the calculator. When I enter the values into the formula and hit enter, I get 7.5. So for part A, the average rate of change is 7.5 feet per miles per hour. For part B, they want us to interpret that value. So for each additional mile per hour, that's the unit of the denominator, the braking distance is increasing since it's positive by 7.5 feet. And that's how you get the units in. We can also calculate the average rate of change from a graph using the same formula. June 2017, number 24. A cardboard box manufacturing company is building boxes with the length represented by x plus 1, the width by 5 minus x, and the height by x minus 1. And here's our graph. Over which interval is the volume of the box changing at the fastest? So they're looking for the largest change. To answer this question, we're going to find out the average rate of change for each of these 4 choices. So I applied the formula to each of the choices. The first one was 9 minus 0, so we estimated f of 2 is 9, f of 1 is 0, 9 minus 0 over 2 minus 1, and that was 9. Choice 2, 3.5 loops around 17. F of 1 is 0, so 17 minus 0 over 2.5, and that was 6.8. For the third choice, f of 5 is 0, f of 1 is 0, so 0 over 4 is 0. And for the last choice, 3.5 is around 17, f of 0 is negative 5. And when I substitute that in, I get 6.4 rather. So the answer to this particular problem is choice 1. Let's skip to problem number 14. In this particular problem, you're given a function, f of x, which involves the trig function, and notice that pi over 2 indicates that it's in radians. We need that information. And that represents a damped sound wave function. What is the average rate of change for this function? And they gave us the interval of -7 to 7. And they want us to take that answer to the nearest hundredth. So let's get busy with this. So the average rate of change formula is the change of y. So in this case, it's f of 7, that's the newest, minus the oldest value, the leftmost value. And that's -7. And that's over the change of our x's, 7 minus the minus 7. So we need to evaluate f of 7. So wherever we see an x in that equation, we're going to substitute in 7. And we are also going to have to do a similar setup for f of -7. And the calculator is really handy for this. So again, this we're going to substitute 7 and this -7. So when we're in our calculator, notice that our value was in terms of pi, so we're going to have to take that into account. Let's first store 7 in x. We're going to hit 7, control variable x. And now we're going to type in the equation with one little catch. So it is 2 caret -0.25x times, and we're going to type in sine, control frac, and it's going to be pi over 2, and here's the catch. You have to enter, this is in radians, so you have to indicate to your calculator that it's in radians, and to do that, go to the pi button, and you should see that R right next to there. Now let's just type in X. X and enter. And that gives you -0.297302. Instead of retyping the whole equation, I can now substitute -7 in for X. So -7 control variable X. And now I can just copy and paste the equation again. So I just scroll up to the equation and hit enter again. So I entered the values into the average rate of change formula and I get -0.261, which is choice 3, which should have been choice 2. Question number 5 is a type of free response question that also involves the average rate of change. You're actually comparing f of x, which is expressed in a table, to an equation. Again, we're going to have to do one for each. So let's first do the average rate of change for f of x. And in both cases, you're doing it over the interval -2 to 4. So it's going to be f of 4 minus f of -2 over 4 minus the -2. The average rate of change for 4, well, f of 4 is 80. F of negative 2 is 1.25. And 4 minus 2 is 6. When we do the arithmetic, the average rate of change for f of x, those are the values presented in the table, is 13.125. So now let's find the average rate of change for g of x. Again, this was f of x. So again, you're using the same formula, g of 4 minus g of negative 2 over 4 minus 2. So I'm just going to do that on the side. G of 4 is 4 times 4 raised to the third minus 5 times 4 squared plus 3. And we're going to also need to find g of negative 2. And we see that's 179. Save some time, store negative 2 in x. And let's just copy and paste. Scroll up to the equation and hit enter. And you get 49. When we substitute into the formula, we get that g of x is 38. We can see that g of x is greater, and you have to clearly state that in your conclusion. So based on the formula, we see g of x has greater average rate of change. Let's skip to August 2018, problem number 7. You're given that the world population was 2,560 in 1950 and 3,040 million in 1960, and it can be modeled by the following equation, where T is time in years since 1950 and P is the population in millions. They want you to again determine the average rate of change from 4 is less than or equal to T is less than or equal to 8. And this is why I wanted to make sure to do this problem with you. They wanted you to provide your answer to the nearest hundredth. So you really have to carry out the individual steps to multiple decimal places. Change your setting in the calculator, go home, hit settings, hit document settings, and instead of being float 6, please make sure that you're in a high value. Float 12 should work, and make it as default in your calculator. Again, you want to apply the formula, so you're going to evaluate P of 8 minus P of 4 over the change in that time period, 8 minus 4. To get the value when x is equal to 4, you could simply copy and paste the prior value, and let's replace 8 with a 4, and we get 2742. Notice that I'm not rounding in between. I hit enter, and to the nearest hundredth is 48.78. And that's how you get those values.